Hello and welcome. Are you looking to add some dynamic effects to your game? Well, in this tutorial, we will look at how to create this cloth blowing in the wind effect using shaders in Godot. So let's get started. So here we are in our scene we will be working with. This is the mesh we want to use. So if we look at that, it's a mesh I made in Blender. It has multiple materials applied to it. And each material uses the same shader. So I already applied the albedo, normal, and this ORM texture and a wind noise texture. And if we look at the shader code here, it's a spatial one. We're using cull disabled since we want to see both sides. And here we have our albedo, normal, ORM texture. And the ORM texture is just a packed texture. So it has the ambient occlusion, the roughness, and the metallic in separate channels. So the RGB. And then we have this wind noise texture that we'll be using for the wind effect. Then we have a uniform to scale our UVs. And then we have this varying texture UV. And the varying just means that we're doing all calculations in the Vertex shader. And then we're passing it to the fragment shader. So we're just sampling our textures, we're unpacking the pack texture, and then we're applying it. We also have some vertex color on the object. Here we have the vertex color. And the vertex color, I just painted it in Blender. So we have it white here in the middle, then it's getting darker here. So it's some kind of grayish here, and at the end here it's completely black. So let's get started. The first thing I want to do is I want some shader globals. So let's go up to project settings. Under shader globals, we're gonna add some new globals. The first one is going to be vector 3, and I'm gonna call it wind direction. I'm gonna set it to 1 in the X axis. Then we're gonna have two other ones. The first is gonna be wind intensity. It's going to be a float. And then we're going to have wind speed, also a float. I'm going to add. And we can set them to 1. So now we have 3 shader globals that we can use in whatever shaders we want. So if we open our shader editor, I'm going to add them here. Let's call them wind globals. And to use the globals we just defined, all we need to do is type global and then uniform. And the first one was vector 3, so vec3 called wind direction. And then another global, also uniform. And this one was a float called wind intensity. And the third one also global, uniform, float, wind speed. So now we can use this in our shader. So now our wind direction is in world space, but we want to convert it to the local space of the object. So we're going to use the model matrix for that, or rather we're going to use the inverse of model matrix. So in our vertex shader, we're gonna create a matrix 3, so a mat 3. I'm gonna call it in model matrix, and it's going to be equal to the inverse of the model matrix, but we're going to do mat3 model matrix. And if you haven't used the model matrix before, this one is a matrix that holds the scale, rotation, and translate values, and it's responsible for bringing your object from local space to world space. And right now we want to do the inverse of that. So bring from world space to local space. And we're doing a mat 3 because we only care about the rotation part, not the translation part. So now we're going to do a vec 3. Let's call this one wind local direction. We're going to normalize. We're going to take our inverse model matrix. And we're gonna multiply that with our wind direction. So now if we push our vertices, so let's do vertex plus equal we're gonna take our wind local direction and let's multiply that with our wind intensity. And let's see how that looks. So now we can see everything moved in the x-axis. So if we go up here in our shader globals, you can see it's moving based on this wind direction. But let's say it's kind of tedious to go up in here in shader globals and change our values here. So let's make a wind controller so we can control this shader global values. So in our wind controller here, so here we have in the wind controller scene, it's just a simple scene with a mesh, and then we have a script on it. And I want this to be a tool, so I'm gonna do tool at the top, and this will mean that we can use it in the editor. And when we're adding a script with the tool, we need to reload the scene we're using it. So I'm just going to go to project. I'm just gonna reload the current project. So what we want to do here in our wind controller, I want to control the wind intensity, the wind speed, and the wind direction. And I want to control the wind direction just by rotating this one. But we can start with controlling the intensity. And to do that, we're going to do an export range. Export range, I'm gonna do between 0 and let's say 5. I want it to go between 0 and 5. Let's also add a step here. So 0.1. And I might want to have the ability to go above 5. So I'm going to do type or greater. So now our slider will be between 0 and 5, but we will also be able to type in a higher value. I'm gonna call this var wind intensity. It's gonna be a float equals, set it to 1. And here I'm gonna do a setter function. So set new intensity. Then we're just going to do wind intensity is equal to this new intensity. And then we want to update our shader globals. And to do that, we're going to type rendering server dot global shader parameter set. And here we're gonna type in what was the name of the shader global, and it was wind intensity. And we're gonna give it the new value, which is also called wind intensity. So let's look if it works. So now we have our wind intensity here. You can see we're changing the shader globals. And we can even put a higher number here if we want to go above 5. So let's do the same for the wind speed. So export range. Let's also gonna be between 0 and 5 and 0.01 for our step, and let's do or greater. It's gonna be a var wind speed. It's also gonna be a float. Let's set it to 1. And let's do the setter function. So new speed, which will be wind speed equals to new speed. And then we need to update the global. So rendering server dot global shader parameter set, and it was called wind speed, and the new value will also be wind speed. Oh, parameter. So now we only need to change the wind direction, and let's do func process. And to change the wind direction, I'm going to use the basis of our model. So let's do the same here. Rendering server dot global shader parameter set. And we're going to set the wind direction. And we want to set it with a new vector 3. So vector 3. And now I'm going to use the basis. And you can think of the basis as how the model is oriented. So we're going to do basis.c and .x. And then we're going to set it to 0 in the y value. And here we're going to do basis.c.c. And let's also do normalized. And now, as we rotate it, we're changing the global for the rotation. But right now, it's updating it all the time. So let's make it so it only updates the global shader parameter when there's a new value. So let's define a new variable. Let's call it previous rotation. And it's going to be a basis equal basis. And in our process here, we're going to do if basis, and we're going to do something called is equal prox to our previous rotation. Then let's just do return. So since we're dealing with float numbers, we're going to use this is equal approx. And it will just look at if the basis and the previous rotation are equal, then we're just going to return. But if they're not equal, then we're going to set it as a new global shader parameter. And let's also update our previous rotation with basis. So now as it rotates, it will only update the shader global when there is a change. And then we can control the intensity. So now we can continue with our shader. And as we can see now, we're pushing the whole object, the whole mesh. But I want this rope things to stay on the metal bar. And we're going to use our Vertex mask for that. So let's go back in the shader editor. So in our Vertex shader, let's define a new float. We can call this one just Vertex color mask. It's going to be equal to the Vertex color red channel, so color.r. So now in our vertex here, let's multiply it by our new Vertex color mask. So now we can see that they're staying in place as we continue to push it. So if we look closer here, we can see it's moving a little bit and then these parts stay the same. So that's nice. Now there's one issue right now. If I keep pushing it in here, you can see this way it's pushing fine. But here we're pushing it beyond. So we're having this weird looking mesh here. We want to limit how it's pushing. So when our wind direction is parallel to this object here, we don't want to push it. Only when the wind is blowing straight at the object. So we can solve this by using the dot product. So the dot product. You can think of the dot product as a value that shows how much two vectors point in the same direction. So how similar they are. So if we have two unit vectors, the dot product of those two will give us a value between -1 and 1. So if we have two vectors that are parallel, the dot product will be 1. And if they are perpendicular to each other, the dot product will be 0. And if the vectors are opposites, then the dot product will be -1. So let's say that this vector is our wind direction, and this is our 3D model. Let's add a vector that is facing down from the model. Now let's overlay these two vectors so it's easier to visualize. And if we look at the dot product of these two vectors, they are currently perpendicular to each other, so that gives us the value 0. And if we start rotating our wind direction, you can see that the dot product value will be 1 when these two vectors are parallel to each other. And if we rotate it back, you can see the value is once again 0 when they are perpendicular. And as we keep rotating it, it will be -1 when they are opposite. So this is what we will do. We'll create a vector that points outwards from our 3D model and then take the dot product of that model direction and the wind direction. So we can see our mesh here, it's in the X direction. So let's do in our shader editor here. I'm gonna create a new vector 3. Let's call this one model. And it's gonna be the front direction. And it's going to be equals to vec3. And it's gonna be 1 in the X-axis. So now this one is pointing this way. So we can use our model front direction and use the dot product between our wind direction and the model front direction. So let's create float. We can call this one just dot product. And it's going to be equals to dot. And we're going to take our model front direction with our wind local direction. And let's also create a new variable. We can call this one strength. And we only care about the absolute values of our dot product. So if they are parallel or perpendicular. So I'm going to abs for absolute values, dot product. And let's also create a new float. This one we can call push strength. And we can do a clamp of our strength. And it can be between, let's say we want a small value here, so between 0.05 and 1. So now in our vertex here, we can use our push strength. So if we go back, you can see we don't have that issue anymore. So that's good. But maybe we don't want it to push as much. We can do a clamp zeros. Now it only will push a tiny amount. So let's get some movement to this. And we're going to use that wind noise texture we had. So if we look at the wind noise, it's just a fast noise with purling on it. So we will drive this one with this wind noise texture. So now let's add this wind noise. We also need a new UV for our wind. So first I'm going to do float wind UV scale. I'm just going to set it to 0.1. Then we need a vec2. And this one is going to be the UVs for our wind noise. So let's call it wind UV equals to vec2. And the first one we're going to take is the vertex.c. So if we look here, for our x values, we're going to take the z-axis of a vertex. So vertex.z, and we're going to multiply it by our wind UV scale here. And we're gonna add time, and then we can have a value to control the scroll speed here. Let's go up here again. Let's create a new float. Float scroll speed. And right now we can set it to wind speed. So here we're gonna do scroll speed. And then for the y value, we're just gonna do vertex.y and multiply it our wind UV scale. So now we just need to use our wind noise texture here with our new wind UV. So I'm gonna do a float called wind noise. It's going to be equal to texture, and we're gonna use our wind noise texture and our new wind UV .r. And this time I'm only going to apply it in the vertex.x direction. So that will mean, if we look at it straight above, in this direction, it will apply this wind noise. We're going to do vertex.x plus equals to our wind noise we created, multiplied by this vertex color mask. So now we have this wind motion here. So if we lower the wind intensity. But right now you can see the wind noise is actually pushing it outwards. And that's because our wind noise is currently in the range from 0 to 1. But I want to remap it so it's between -1 and 1. So it both pushes out and inwards. And we're going to unpack it. So unpack wind noise. And it's from 0, 1 range to -1 range. So we're going to do wind noise equals, and we're going to take 2 multiplied by our wind noise -1. So now we have remapped our wind noise from 0 to 1 to -1 to 1. So now you can see it's moving in both directions here. But let's also have it be affected by the wind intensity. So I'm gonna multiply it by wind intensity. But it might be a bit strong, so I'm just going to multiply it by half of wind intensity. And also, I might want to limit how much it moves based on the dot product on this one as well. So in our push strength, let's also create a new one. So float, this one is called noise strength. And let's clamp this value between, I'm gonna clamp the strength value between 0.5 and 1. So now if we have this one here called noise strength, and let's remove this one. So now we can see the effect is stronger if it's perpendicular to the model. compared to if it's parallel. So now I want to change the scroll direction based on the direction of the wind. And we can use the dot product once again. This time I want to use the model's side direction. So I'm going to do vec3 model side direction. vec3 0 in x, 0 in y, and 1 in z axis. So now below our dot product we can do float side dot. We're gonna just do the same thing. Dot model side size side direction with our wind local direction. So now we can use this to create the scroll direction. So float, we're gonna create a new variable called scroll direction. We're going to use the sign, and the sign function will give us, if the value is a positive number, it will give us the value 1, and if the value is a negative number, it will give us -1. So we can do the side dot there. So then in our UV here, wind UV, right after scroll speed, we can just multiply that with our scroll direction. So if we rotate this one, now it changes direction, but it's the other way around. So we know scroll direction. Let's just multiply it by -1. So -1 multiplied by sine side dot. So now it's changing wind direction. Or scroll direction. But now they're all having the exact same animation to them here. I want to create some kind of offset, so they're not playing the same thing at the same time. And we're going to use the world position for that. So we're going to create a new function here above the vertex shader. And as we have done in previous tutorials, we're going to do a float. We're going to call it get position sum, and the parameter is going to be vector3 world position. And then we're just going to return the sum of x, y, and z axis. So return world position dot x, and we're going to add world position dot y and world position dot z. Let's create a float. Let's call this one position sum. It's going to be equal to get position sum, and we're going to pass it the node position world. So all we need to do now is use this one. So right below our wind UV scale, I'm going to create a new one. I'm going to call float wind object offset. It's going to be equal to the position sum, and then we can multiply it by a value here. And in our wind UV here, after scroll direction, I'm just going to add this wind object offset. And that should make them not play at the same time. And you can always change this multiplier value here if you want a greater value to offset the animation between each other. So if you multiply it by 0, it's gonna have no offset at all. And as you increase it, they're gonna offset more and more. So now you can also play around with this wind noise value here. You can try different kind of noise patterns and frequency to whatever effect you're looking for. So there you have it. That's how you create this kind of noise wind direction to your models.